Okay, so we're going to do some multivariable calculus. We're going to try and solve the Euler Lagrange equation for this functional here. So it's the integral from a to b with regards to x, y times the square root of 1 plus y prime squared. So the Euler Lagrange equation, one way we can do this is do total derivative of the partial of this functional f with regards to y prime minus the partial of f with regards to y, and set that equal to 0. That will be one way. But having a look at this functional here, it's not explicitly dependent on the variable x. So what we can say is this functional here, f, which is regards to y and y prime, there's no x in there, so this will reduce to a first order equation. So we can use something called the first integral. Now the first integral, we can write this as f minus y prime, and then we multiply this by the partial of f with regards to y prime, and then this will be equal to a constant, any constant. So that's our first order our first order equation. So we know what f is. So f is just this. So let's just write that up there. So f equals y times the square root of 1 plus y prime squared. So we know that. Y prime we can just write as y prime. So if we find this partial of this with regards to y prime, then we're on our way to finding what our equation is for the constant. So let's try and find that. Partial of f with regards to y prime. Okay, so we've got y times square root of 1 plus y prime squared. So as it's a square root, as in from our calculus 1 days, we know that that becomes 1 over 2 times whatever's in the square root. So that's square root of 1 plus y prime squared. So that will stay. The y, when we're taking the partial with regards to y prime, that's just a constant. So we can leave the y up here somewhere. So if I just put the 1 in brackets and the y in brackets, and we can see that they are separate, as in multiplied. And then using the chain rule, we take the derivative of y prime squared and put this in our numerator. So then we end up with 2y prime. So we can simplify this off a little bit. The two 2's cancel, so that cancels. And then what we're left with is y times y prime over the square root of 1 plus y prime squared. So that's our partial. So now we can write this here, because we've got all the terms now. We've got the f, the y prime, and we've got our partial. So let's write that. So we've got f, which is y times the square root of 1 plus y prime squared. That's all good. Subtract that from y prime. Let's put that in brackets so we can see that it's separate. And then multiply it by this partial here. So y prime, we can put this all over together because these are multiplied. So we can just write this square root in the bottom, 1 plus y prime squared. Then all this will equal a constant. And I'm using the letter C, you can use the letter A or B, whatever letter you want to use. Okay, so now what we want to try and do now is isolate y or y prime. So it's looking a little bit messy here. We've got a square root in our denominator, so having this here is a little bit awkward. So let's multiply everything by square root of 1 plus y prime squared. So square root 1 plus y prime squared. Let's multiply every term by that. So multiplying this term here, the square root will just disappear. So then we'll end up with y times 1 plus y prime squared. And must remember to keep writing that 2 up in the top there. Okay, let's put this 1 a little bit lower so it doesn't look like a 12. Okay, 1 plus y prime squared, so that takes care of this term. Now this term here, if I multiply this with this term will just cancel out. So then we're left with y prime times y prime. So we're left with y times y prime squared. And then we've got to multiply this constant by this radical here. So that gives us c times the square root 1 plus y prime squared. Okay, now that's a good start. Now let's have a look, see if we can multiply this out. So we've got a y prime squared here and a y prime squared here. So maybe there's a factor or some sort of cancellation we can do. So let's multiply this bracket out and see what we end up with. So we've got y, distribute that in here, and then distribute it with this one. So y plus y times y prime squared minus y times y prime squared. Now that is looking very good. We can see straight away there's a cancellation, and that equals c times the square root of 1 plus y prime squared. Okay, now that cancels out, so that's brilliant. That's worked in our favour really well. So now we're left with the y isolated. So let's take care of that now. So let's just write it up in just nice and neat form. C square root 1 plus y prime squared. Okay, now I want to try and get this y prime out of this radical term. So why not, let's just square everything. So let's bring everything up here and start again. So squaring this, so let's just put a term around there and just square it so we can see what we're doing. So now we've got y squared. Square this, you get c squared. And square the radical, you're just left with 1 plus y prime squared in brackets. 1 plus y prime squared in brackets. Okay, now we can get this 1 plus y prime squared and the c squared. We can get all these apart now. So now we can do y squared over c squared. That'll be good. So we can separate that from the y prime, and then maybe we can integrate and get these things separate. So y squared over c squared. So divide both sides by c squared. We've got y squared over c squared equals 1 plus y prime squared. And then what we do is then just subtract 1 from both sides. And I'm going to just to help me here, I'm going to bring the y prime over this side. So y prime squared equals y squared over c squared minus 1. Okay, this minus 1 on its own, I'm not liking the look of that at the moment. I want to have a c squared and then put something in the numerator that's the same. Well, for 1, I could just write that as c squared over c squared. I've still got 1. So then I could be left with y squared minus 1 over c squared. So let's do that. So y prime squared equals y squared minus c squared over c squared. So that takes care of that. Now what I want to do, get rid of this squared term, and then we're ready to integrate with a little bit of algebra. We can see we could get somewhere with that. So let's go take square root of this side. That's fine. Square root of that side, we're going to be left with this term. So y prime equals square root, and don't forget our plus and minus. So there's 2 solutions here. And then y squared minus c squared over c squared. Okay, now that is good for us so far. So now what I'm going to do is I'm going to rub this out on the board. So just make a note of this, bring this on its own up the top, and then be ready to integrate and see if we can get y on its own. Okay, so now I've written our equation up here that we've got so far, making sure we can see that everything here is inside this radical. Now we want to try and get y on its own. So we've got y prime and we've got a y. Well, we know y prime, we can just rewrite that as dy. Basically, it's the derivative of y. So if we do that, then we've got two y terms, and then we can maybe try and isolate this term here and see what happens. Okay, so let's rewrite it like this first. So dy equals plus or minus square root y squared minus c squared over c squared. Okay, we want to get the y's all over onto one side. So if we just divide both sides by this radical, let's see what we got. So we've got dy divided by square root of y squared minus c squared over c squared. So that brings that over. And then plus or minus, well, if you divide this by this, we're just left with 1. So that takes care of that. Now this is just a little bit ugly, this c squared and c squared here, in a dividing inside the radical. So good old fashioned, back to our old fashioned surds, we can rewrite this. Dy equals square root of y squared minus c squared, and another radical. This c squared here is just basically 1 over c squared. So that takes care of that. That's great news. And then plus or minus 1 in the other side. So we come back to that when we're integrating. Now this square root of 1 over c squared, let's just take care of this over here and see just exactly what's going on. 1 over c squared. Well, if we take the square root of that, we're just left with 1 over c. So this here, we'll just cancel this out and just write 1 over c. So that's square root of 1 of y squared minus c squared times 1 over c. All we've got to do now is just flip that and we can put the c in the numerator. So let's just do that. So c times dy over the square root of y squared minus c squared. So that takes care of that. That's looking very handy. Equals plus or minus 1. Okay, well that's now looking like something we can integrate. So this dy, if you don't like the dy in your numerator, then we just wrote the dy here. Basically what we can do is now, is just an integral sign here with regards to dy, and this side we can integrate with regards to x. So if I just give yourself a little bit of space there, 1 dx, and now we're ready to integrate. Well, the right hand side is easy, that just becomes plus or minus x, that's fine. Now this one here, we can bring the c out front because we're integrating with respect to y, so the c doesn't matter, but the radical will have to stay as it is. So let's just rewrite that. C times the integral of 1 over square root y squared minus c squared with regards to y equals, I'm just going to leave this as it is for now because we know what that is, that's simple. Now this one is a famous integral, it's got two forms. So square root of y squared minus c squared, we've got a choice. We can either write this as in this integral here is the hyperbolic cosine, the inverse of, or the arc inverse hyperbolic cosine, is cosh of this term y over c, because that's our terms inside here, or we could use the natural logarithm version, which is the natural log of absolute value of y plus square root of y squared plus c squared, and close the absolute value, and then mustn't forget our constant multiples in both cases, which we'll use d this time because we've already used c, so we need a new constant multiple. Okay, so I'm just going to write that up here now. So I'm going to use our hyperbolic cosh. So cosh inverse cosh. So with this c, all I've got to do now is just multiply this version here, and then I've got the solution to this integral here on the left hand side. So if I just write an arrow here, showing I'm going to here. In fact, we can take these little bits off here because we don't really need those. Let's give ourselves a little bit more room. Okay, so we can write here now C times inverse cosh. So I'll put the C in brackets. Inverse cosh y over c plus our constant multiple d for this integral part, and that will equal plus or minus x. And we don't need to put a constant multiple on this side, we've taken care of it on this side. Okay, so now we're in a little bit of a mess here because the y is inside this trigonometry a symbol here. So how can we get rid of that? Well, if we take the cosh of both sides, we can get rid of this inverse cosh here, because that will then cancel out because they're both inverse of each other. And before we do that, if we just divide both sides by our c and bring our d across, we're ready to take care of it. So if I bring the d across, so we've got plus or minus x, and that's minus d, and then divide it by c. So divide all of this by c. That just then gets this term here on its own. So that's fully legit here. I'll just bring the d across first, and then that will leave me with this, and then divide by c, which I've done here. Okay, so now I'm going to take the cosh of this side. I'll also need to take the cosh of that side as well. So now I'm going to have cosh of inverse cosh of y over c. That takes care of that. And now I'm just going to need to fit the cosh of this function here. So I'm just going to take this away. So then I'll put the equals here, fit my cosh in there nicely, and that takes care of that. Okay, now I can deal with this. This is going to be one part of the final answer. So coshes cancel out. I've got y over c equals cosh of plus or minus x minus constant multiple d divided by the original constant multiple c. And now what I'm going to do now is multiply by this c, and I've got my y on its own. So y equals c. I'm going to put multiply there so you can see it. If I put the c next to it, it'll look a little bit weird. Cosh of plus or minus x minus d over c. And that's our values for y that we've got. So y equals c times cosh plus or minus x minus d over c. And that takes care of this part of our calculation so far. But then we've got our boundary points here of a and b. Now if we are, for example, told that at y of a equals a and y of b equals b, these are typical boundary points on a multivariable integral like this one. So now what we need to do is just write them for this in terms of this, and then we've got our solutions. So for y of a, so if I just write this one here, y of a, so now all I do now is wherever I see an x, I'm going to write an a. So y of a equals c times cosh of plus or minus a minus d over c, and this will equal a. That's our boundary point for our variable a. And then for the other boundary point, y of b, so y of b, now I'm going to write c times cosh of plus or minus b minus d over c, and that will equal our boundary value b. Okay, there we go.